Hi students, in this video I am explaining various concepts for solving numerical of friction. A car of mass m is moving with speed u and brake is applied so that it travels a distance s before stop. Find frictional force and coefficient of friction between wheel and road. Suppose this is a car. This car is moving with speed u and after traveling a distance s, the speed of the car becomes 0. That means v is equal to 0. So initial speed of the car is equal to u. Final speed is equal to v is equal to 0. And distance travel this is equal to s. As the final speed is 0, that means there is a retardation acting on the car and there is a retarding force. That retarding force is due to the friction between wheel and the road. So we can calculate the retardation here. Now we can use the formula v square is equal to u square plus 2as. Now final speed is 0, initial is u, as it is retarded motion, so this is minus a to s. Therefore a is u square by 2s. Therefore frictional force, which is equal to retarding force is equal to F is equal to m into a. So m u square by 2s. Next we have to calculate the coefficient of friction. As the car is moving forward and frictional force is acting between the wheel and the road, then total friction, that is F mg is the weight of the car and R is the reaction force. From laws of friction, we know that frictional force F is equal to mu into R. As the car is moving horizontally, so there is no net vertical force acting here. Therefore, R is equal to mg. So, m u square by 2s is equal to mu into mg. Therefore, mu is equal to u square by 2gs. A block of mass m is placed on a smooth horizontal ground. Another block of mass small m is placed on capital M. The coefficient of static friction between two blocks is mu. Now F force is applied on larger mass. Find the value of F so that small block tends to slide over large block. Now in this question, force is applied on capital M in this body. Now, as this larger block is placed on smooth surface, for the lower part there is no friction acting. but in the upper part there is a friction. Now when F force is applied, then this block tends to move towards right. This block tends to move towards right. So there is a relative velocity towards right with respect to small m. With respect to small m. For that reason, the frictional force, this is oppositely directed. That means frictional force acting in this direction. This is F. Here frictional force. This is F. Now if we consider the free body diagram for larger block, F force is applied in this direction and the frictional force, this is F. This friction is F is here frictional force by small m on capital M. Now from Newton's third law, same force, that means same frictional force is applied on small m by capital M. Therefore, if we consider the free body diagram for the smaller mass m, here frictional force is applied in this direction. This is frictional force on small a, on smaller block by capital M. We have to calculate the value of F when M tends to slide over capital M. That means this smaller block is not moving over larger block. It having a tendency to move. So the frictional force here acting, this is the limiting friction. It is very important. This is the limiting friction applied on small m. What is the value of limiting friction here? Here, if you consider the free body diagram, mg is the force applied and r is the reaction force. Then frictional force F is equal to mu into r. This is mu into mg. As small block tends to move over larger block, therefore it experiences a balance force. That force is provided by the pseudo force. As capital M is moving towards right and small m is placed over it, so small m experiences a pseudo force towards left. This is the pseudo force. This is P. Here P is the pseudo force. Therefore, P is equal to mu mg. As two blocks are moving with same acceleration, and if we consider two blocks as a system, then we can say that this is capital M, F force is applied, and here small m is placed over it. So the frictional force experienced by capital M due to small m and frictional force experienced by small m due to capital M both are considered as internal force whenever we consider small m and capital M as a total system. Therefore, we can use this formula F is equal to ma. So net force F is equal to mass, total mass into acceleration. Therefore, acceleration is equal to F by m plus m. So pseudo force, that is P, this is equal to m into a, and here we can write F m by m plus m. Therefore, Fm by m plus m is equal to mu mg. Then we can write F is equal to mu m plus m into g.